Okay, so this video is a really nice video. We're looking at solving one-step equations, and look, this in essence basically means, right, solving equations like this, right, x plus 5 is equal to 11, right, and people always say, oh, this is really easy, I can see that x is equal to 6, right, because 6 at 5 equals 11. What's happened there? So x would be equal to 6, but I'm not interested in that. I'm interested in how we properly solve one-step equations using balance method. Okay, so this is a really important video, and if you watched the previous video on writing algebraic expressions, this is going to be revolutionary in your understanding of solving equations. Okay, so sit back, get a notepad and pen, and enjoy the ride on this video. Okay, so we saw previously, right, if I gave you the statement, I'm thinking of a number, I add 5 to it equals 11, we would write it as this. So you could use a different letter or a different variable, but in essence, a number x add 5 plus 5 equals to 11, okay? And we're looking today at how we solve this equation using balance method. Again, I'm not interested, if you're looking at that going, oh, this is easy, x is 6, I don't care, right? That might seem a little bit crackers, but it's because I want you to understand how you properly solve an equation. Because when you get given an equation like this, x divided by 2, take away 3, you square it, and it's all equal to 2, for example, you won't have a clue what to do if you don't understand the fundamentals. So this is important, this video. Okay, so here's the question, right? Solve this equation. Solve, right, means you want to find this missing variable. In essence, you want to get x to be equal to something on its own. There we go, right. And this idea is so the way I think about solving equations, which was taught to me by a very amazing teacher, right? And I love this idea, is using scales, right? We've got an equation, we've got an equal sign. So we're saying the stuff on the left-hand side, x plus 5, is equal in value, in this case, the analogy of weight, to the stuff on the right-hand side, equal to 11. So currently, my scales are in perfect balance. X plus 5 is exactly in balance with 11. Okay? Now, solving an equation is like untying a knot. You do the opposite to how you tied the knot. So if we looked at, right, how we tied the knot, what I mean by that is, if we consider this x plus 5, we know, right, from the last video, that we started off with x, and when you added on 5 to that, you just add 5 to give you x plus 5. That was when the equation was formed, as we saw previously on the last video. Now, when you solve an equation, you do the opposite. So you go backwards. So what is the opposite of a plus 5? Well, the opposite of adding is to subtract. So when you solve this equation, you've actually got to take away 5 to get you back to x, because it makes sense, right? X plus 5, if you take away 5, you get back to x. So when solving this over here, right, I begin by subtracting 5 from the x plus 5. So I take away 5 from this. Now the issue is, if I do this, okay, the scales become unbalanced, okay, because I've done something to one side of the scales, which means everything becomes unbalanced. So this idea is really important. If you do one thing to one side of your equation, you must do the same thing to the other side to keep it in balance. Because I took away 5 over here, I must do the same thing over here. So I've now taken away 5 from the 11 as well, because now the scales are back in balance. I've done the same thing to both sides, and that's really important. I'm back in balance. So now if I continue on, so we're at this stage here, and this idea is really useful, because I've got a plus 5 and a take away 5. The whole point of taking away that 5 is to cancel out these two here, because effectively plus 5 take away 5 is 0. They cancel, they disappear. Okay? I'm left with, well, the 5s here have disappeared. They cancel out. I'm left with an x, which is over here. So I've got an x left over, being equal to 11 take away 5, which is 6. And I've solved that equation, right? I found my value of x, which is 6. X is equal to 6. And let's check it, right? If x is equal to 6, I've got 6 plus 5 equals 11. It makes sense. I've solved that equation using balance method. Okay? Let's look at another example. This one, it says solve x divided by 4 is 12. So it's just saying really what number divided by 4 is equal to 12. But let's consider this again using the analogy of our scales. So initially, right, everything is in balance. I've got my left-hand side, x divided by 4, being equal to, in weight, being equal to 12, which is over here. And again, right, solving an equation is like untying a knot. We do the opposite to how you tied the knot. So we know, right, when the equation was formed from the previous video, right, if we just consider the x divided by 4, we know that when it was formed, we began with x, and then we simply just divided it by 4. So we divided it by 4 to give us this x divided by 4. Now, when you solve the equation, solving, you do the opposite. So you've got to go backwards now. And what's the opposite of dividing by 4? Well, division and multiplication are opposite. So opposite of dividing by 4 is to times by 4. Because if you times this by 4, the 4's cancel and you go back to x. So if we look at this over here, I've got x divided by 4. So to solve this, I've got to times this, first of all, by 4. But we now know, right, because I've done this to one side of the equation, the scales become unbalanced. With balance method, you must do the same thing to both sides. Otherwise, everything becomes unbalanced. So with the 12 also, I must also multiply this by 4. I can do whatever I want to an equation, but I've got to do the same things to both sides to keep everything in balance. That is crucial. And the reason I times by 4 here was because, well, to solve it, to get back to x on its own, okay, the opposite of dividing by 4 is to times by 4. Okay, let's continue on. We've got to this stage here. Well, importantly, right, the opposite to divide by 4, we said was to times by 4. And this is important because now these two will cancel out, which leaves you just with the x, which is good because we're trying to find x. That's the aim of the game. So we get x on its own, which is good. And you've got 12 times 4, which gives you 48. So we've done it, right? We've got x to be on its own. X is equal to 48. And let's check it into our equation. If x is 48, well, 48 divided by 4 indeed is equal to 12. So I've solved my equation. X is equal to 48. Okay, so this idea is incredibly useful when looking at solving these one-step equations. So we're going to go through some my turn, your turns now, and we can always relate back to now the weight scale analogy. Okay, so solve the following one-step equations. So we've got w plus 7 is equal to 22. Now, I'm trying to solve this. For the first one, I'm trying to get w to be equal to something. And I saw previously, right, well, how would I get rid of that plus 7? When it was formed, it was w, I added 7. Well, the opposite, because when you solve an equation, it's like untying a knot. The opposite of adding 7 is to take away 7, okay? But you must do that on both sides. So now really you're seeing, because obviously when you do questions on this, you're not going to be drawing out scales all the time. You would be there forever. Yeah? This is how we do it in practice. So the opposite of adding 7 is to take away 7, and you must do it to both sides. And this is good, because what happens now? These two, they cancel out, which is good. And you're left with the w. So you're left with w being equal to 22 take away 7, which is equal to 15. And this is your solution. This is your answer, okay? And the beautiful thing about solving equations is you can always check your answer. The equation was w at 7 is 22. Well, if w is 15, we've got 15 add 7 indeed equals 22. So you know it's definitely correct. Good. The second one, we have y divided by 3. So you had y, we then divide it by 3 to give you y over 3. And then when you solve this, we go back in the opposite direction. So what's the opposite of dividing by 3? It is to times by 3. Division and multiplication are opposite. So here, we would multiply, okay, both sides of the equation by 3. You have to do the same thing to both sides, the left-hand side and the right-hand side. And this is good because, well, timesing and dividing by 3, these are inverse operations. These cancel out. Okay, so you're left over with y. So y being equal to 9 times 3, which is 27. And this is your solution. Okay, so there we go. And again, the beauty of solving equations is you can check your answer. If y is 27, well, 27 divided by 3 indeed is equal to 9. So perfect. Good. Last but not least, we've got 4. This 4x means 4 times x. So we began at x. We then multiplied it by 4 to give you 4x. And again, when you solve it, you do the opposite thing. You're untying that knot. So the opposite of timesing by 4 is to divide by 4. So here, we divide both sides, you must divide both sides of the equation by 4. Okay, and 4 divided by 4, they're opposite, they're inverse, they cancel. And this leaves you over with just the x. So you're left with x being equal to 20 divided by 4, which is equal to 25. So there we go. And again, you can check this because looking at the initial equation, well, 4 times 5 is 20. So it makes sense, which is good. Okay, so you can now solve these equations here using balance method. I'm not interested in you just writing m is equal to something. I want to see the working that you can see over here. This is incredibly important. Okay, so solve the following equations, right? So you can give these a go yourself, and I will go through these now. The first one, we've got m take away 3 is equal to 14. So I'm trying to get m to be on its own. And now I'm solving this, I want to do the opposite how it was formed. I had m, I took away 3. The opposite of taking away 3 is to add 3. And I must do that to both sides of my equation. Now, these are going to cancel because they're opposite. They cancel, which is good. I'm left over with m, which is perfect. M being equal to 14 plus 3, which is 17. So this here is my answer. And again, let's check it. Right, is 17 take away 3 14? Yes, it is. Good. This one, I've got b divided by 2. So I had b, I had divided by 2. Untying a knot, what's the opposite of dividing by 2? It is to multiply it by 2. And I must do that on both sides of the equation. Then these two here are going to cancel because they're opposite. That's the whole point of doing this. And then we've got a b left over. So you've got b being equal to 14 times 2, which is 28. Okay, there we go. Last but not least, we've got, and again we can check it, sorry, if b is 28, or 28 divided by 2 is 14. So if you wanted to write it out and check it, we can do, well, b is 28. If we divide it by 2, we get 14, which is really good. Last one, we've got 2k equals to 30. Again, you had k, right? 2k means you times it by 2, so you multiplied it by 2 to give you 2k. Solving it, you're untying a knot, you're going back. What's the opposite of timesing by 2? To divide by 2. And you must do that on both sides. Okay, and this is good because if you times things by 2 and dividing by 2, they cancel, which is good. And you're left with k being equal to 30 divided by 2, which is 15. So this is our answer. 15 goes there. And we can check our work again. Let's check it in green. Let's get rid of this. What is 2 times 15? It is 30. Yeah, 2 times 15 equals 30. Good. We've checked our answers. So hopefully this idea was really useful in understanding why when you see this stuff, like when people are always like, you know, you do the opposite to both sides, you've got an understanding now that, okay, you can think back to the scale, the weight analogy, the way of looking at things. Okay, thank you.